So in this video we are going to focus our attention on earth geometry. All right, so our our main area of focus in this video under earth geometry is first we say stating the position of a point on the earth's surface. Then second, that is calculating distance, okay, either along the longitude or the latitude. All right, so this is our main area of focus in this particular video. All right, so when you're given sometimes when you're given a question under earth geometry, sometimes it's drawn for you. Maybe they ask you to state the position of that point, or sometimes it's not drawn for you. They've just given you the particular points, then they ask you to illustrate those points that you're given on a diagram. Like you draw a diagram, then you put those points on that particular diagram. So in the case where you're already given a diagram and you are just asked to state the position of a certain point on the Earth's surface, whether it's A, B, or any letter that is used, or sometimes they use a town, maybe they say town A, town B, town C, town K, so on and so forth. So before you do that, one thing that we need to keep in mind is this: on the Earth's surface we have latitudes, they are horizontal, then longitudes, they are more of vertical. All right, and another thing that we need to keep in mind is that for me, of course, these are not straight lines, but for me it was the easiest way that I used to remind myself of which one is the latitude and which one is the longitude is that I used to relate the latitude with x and the longitude with y. Of course, these would represent the straight lines, but yeah, I used to see it in that case to make my work simple. All right, so for example, if you have a point here, let's say this is point A, then you are to say this longitude is let's say 50 degrees west. Then this latitude, we say it is 20 degrees north. So now someone asked you to state the position of this point. All right, so what you do is that you put A here, you open the bracket. So the first position that you put, to say, you need to tell the person who's asking this question to say, okay, now where is this, on which latitude is this point A lying? And of course it's latitude 20 degrees what? North. Don't just write 20 degrees, put the north, because there are a lot of latitudes that you can be given, but so you need to be specific to say it's 20 degrees north. Then for the longitude, is also lying on longitude 50 degrees west. So another thing that we need to keep in mind is that the latitude, it's either is north or south. Then the longitude is either is east or west. It's more like when you draw this. Okay, this is north and this is south, this is west and this is east. All right, so you find that this line, we can call it the GM, okay, the Greenwich meridian. Then this line we can call it the equator, which is 0 degrees as well, same as that one. So whatever line is, whatever longitude is after the Greenwich meridian, this side is east. Whatever is before the Greenwich meridian is west, and whatever is above the equator is north, and whatever is below the equator is south. Okay, so in whatever point that you are given, just look at the latitude and take the longitude as well. Then you easily state the position of that point. And please keep in mind, as I said, when you write, for example, this one is 20 degrees, don't just write 20 degrees. No, tell the person who is asking to say this is 20 degrees on what latitude? Of course is north, because it's either it's latitude, the one that is in south, or the one that is in north. So now in terms of calculating distance, all right, so it's kind of different. If you're calculating distance along the longitude and along the latitude, it's a bit different. So in this case, we talk about the formulas now. If you're calculating distance along the latitude, then you just say longitude. Here are the formulas that you use. If it's distance along the latitude, you just say theta over 360 multiplied by 2 pi pi r cos, we can say x or alpha, something like that. Longitude, we just say theta over 360 multiplied by 2 pi r. You can use calculator r right there. So now, what is this cos doing in this case on this formula? When you're calculating distance along the latitude, why do you introduce a cos? Because the figures of the radius that are given of the Earth's surface are we have two. There's one in kilometers and there's one in nautical miles. So I find that whenever you're given a question, it's indicated in the brackets that you find to say the radius in kilometers is in km, say kilometers is equal to 6,370. Then in nautical miles, it is 3,437. All right. So now, why is it that on this formula we are introducing a cos? It's simply because when you're calculating distance along the latitude, because the Earth's surface is more like this. Please pardon my drawing. So I find that when talking about the longitudes, all the longitudes have the same radius. The distance of all the longitudes is just the same. Now when talking about the latitudes, the equator is 0 degrees, automatically 0 degrees. So I find that the equator is bigger compared to the other circles that you're going to cut. So when you cut here, you have reduced the radius. When you cut here, you have reduced the radius. So this cos is just here to reduce the radius that as you are calculating the distance. For example, this one has 0, of which if you're calculating distance on, like, for example, if you have a point here and a point here, calculating distance between these 2 points, you're going to say cos 0, of which cos 0 is going to give you 1. So the purpose of this cos in the formula is just to help us reduce the radius, because the radius of the latitudes are different compared to that of the longitudes. All right. So in this case, in terms of calculating distance, we are going to use the question that came in the 2021 paper 2 GCE math. All right. So as the question says right there, it says the points A, B, C, and D are on the surface of the Earth, as shown in the following diagram. So we are given to say the radius in kilometers, we are given 6370 kilometers. Then in nautical miles, we are given 3437 nautical miles. Then the first question says, determine the difference in longitude between A and B. All right. So we are given, okay. We are given something like this. Okay. Something like that. Then here we have point A, point B, point C, and point D. All right. So then we are given to say this is the center of the circle. All right. So the angle here we have 52 degrees. Then the angle that is right here we have 85 degrees. All right. So when you look at the angle that is here, this is the angle between C and D. Okay, and we are given to say this line is the GM, Greenwich Meridian. Then this line is the equator, just indicate using 0 degrees. Then we are being asked to determine the longitude, the difference in longitude between A and B. This 85 degrees is the longitude difference between C and B. But what helps us to find this 85 degrees is because of the longitude on which C and B lie, of which again it simply means, it's simply implied because A and C are lying on the same longitude. B and D are lying on the same longitude, which also means the longitude difference between A and B is also 85 degrees. Okay. So when you look at this, the Greenwich Meridian is 0. So here we have 85 degrees. It simply means this longitude is 85, because for us to find this, for us to find the angle, the the angle between C and D, we had to add what is here and what is here. Here we have 0 degrees and here we have 85 degrees. When you add them, you're still going to get 85. But if this line was not the Greenwich meridian, if it was a line in the west, meaning we could have subtracted west and east, you subtract. Okay, yeah. So sorry, I meant if it's west and if they are different, you add. If they are the same, you subtract. For example, if this was also east, this is also east, you subtract. But if they are different, that is west and east on the other side, that's when you are going to add. Okay, so we have answered the first question, and the second question is asking us, say, calculate distance between C and D along the equator in nautical miles. So we are calculating distance CD. So remember, this is distance along the latitude. Hence, we are going to say this. We are going to say theta. Here, I'm just going to say CD is equals to theta divided by 360 multiplied by 2 pi r cos x, like that. So now, what is our theta? Our theta is 85 degrees divided by 360 multiplied by 2 by 3.142 by the radius. Remember, we're calculating nautical miles, so you say 3437 multiplied by, we say cos what? 0. Okay, so when you put all this work on your calculator, we say 85 by 2 by 3.142 by 3437. Remember, cos 0 is equals to 1, so just more like leaving it out. That's what we are going to get. Going to get something like 1835,839.18, like that. So then we divide this by 360. So divide by 360. Okay, we are going to get something like 599.5532558. But remember to say we need to round this off to 3 significant figures. Hence, we are going to have something like 5100. That will be our final answer. That is nautical miles. So in another words, again, remember to say this is the main formula that you use, but there is another way out, the easiest way out to do it, just in case you're dealing with paper 1. You should always keep in mind to say 1 degree is equals to 60 nautical miles. 6 nautical miles. That is, this formula I use it when you're calculating distance along the longitude, but if it's along the latitude, you include cos x there. So if 1 degree is equals to 60 nautical miles, what about 85 degrees? Put x here. Remember to say here this cos is more like we have 0 here. So you find that when you use this formula, you are going to get a figure that is already rounded off, meaning you're just saying 85 multiplied by 60. That is going to give us 5,100, of which that is what we found here. Remember to say this one was not yet rounded off, but for this one, it's already rounded off. Okay, so the second question is asking us to find the distance along the longitude NBDS in kilometers. All right, so remember to say we have this longitude, we have N here, we have point B here, then we have point D somewhere there, then we have point S. Then we are being asked to calculate distance along this. So we need to keep in mind to say, in simple terms, we're just calculating distance between B and D. All right, and the angle difference between B and D is 52. So of which that 52 simply means is 52 degrees north. Why? Because D is on the equator, and the equator is 0 degrees. So it's more like you added and got that. All right. So here what you're going to say is BD in terms of distance is theta divided by 360 multiplied by 2 pi r. You just leave it at there. Remember to say you don't include the cos, because the radius for longitude is the same for all. Yeah, so here the angle difference that you have is 52 degrees divided by 360, multiply it by 2 by 3.142. Okay, 3.142 multiplied by the radius in kilometers. Now it's 6,370. All right, so when you go to your calculator, we say 52 multiplied by 52 multiplied by 2 by 3.142 multiplied by 6370. What you're going to get is this figure here. Okay, I'm getting 2,081,512.16. So you say 2,081,512.16 divided by 360. Divide by 360. What you're going to get is 5,781.978222. So if you round this off, you're going to find that to say this will give us 8, this will give us 10, then you're going to get a 1, you put it there, right? So this will be 5,782 kilometers. You have rounded off. But in case this, for example, if this was 4, then you round off, it gives us 5. You need to give the 1 to 8, meaning this will be 9. Why am I saying so? Because you are being asked to round off to 3 significant figures. But since here is a number that cannot give to the number before it, you are not allowed to do anything. Just leave it like that. And again, if we omit the 2, we are going to disrespect our answer in simple terms, because this is 1,000. So if you remove a 2, you're going to make it 100, and that will make your answer wrong. Yeah, so that's all from this video. Thank you.